All right, my friends, let's take a look. I'm going to do the partial fraction decomposition off to the side, and then I'll come back and put it all into the integral later. So we've got 2x minus 3 over x minus 1 squared. The form, since it's a repeated linear factor, would be a constant over x minus 1 plus a constant over the quantity x minus 1 squared. From here, make sure that you don't just kind of do what some people do with these, where you kind of do like a cross multiply thing. That's going to create a mess of great proportions, because no pun intended. Dun, 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 shh. Anyway, because at that point you wouldn't be getting the denominator x minus 1's quantity squared. You'd be getting x minus 1 cubed, okay? And so it's going to create a big mess and waste a lot of your time. So instead, make sure that when you multiply your fractions by a creative version of 1, you're multiplying it by a version of 1 that will get the denominator you started out with. So what that means is, it's actually good news in this case, is that your first fraction with a should be multiplied by x minus 1 over itself, and your second fraction doesn't need to be multiplied by anything because it's already over x minus 1 squared. And then from there, you'd have ax minus a plus b over x minus 1 squared, and you have won the denominator battle. So now all you have to do is set the numerators equal to each other. 2x minus 3 would need to equal ax plus the quantity negative a plus b. All right, so what does that mean? That means that the number of x's should match, so a should be 2, and then your constant terms should also match. So negative a plus b would have to equal negative 3. And since a we know is 2, you could just replace the a with a 2 and then add the 2 over. So b would equal negative 1. There we go. Okay, so taking these two values and putting them back into the form, we could rewrite the integral as the integral of 2 over x minus 1 plus, or I guess I'll say minus 1 over x minus 1 squared dx. There we go. Okay, now I'm going to think of this as two separate integrals. Let's see, the first one, I'm going to factor the 2 out. And then the second one, I'm going to write it like that. For both integrals, the same u substitution would work very nicely. If you let u equal x minus 1, your du would equal dx. So your first integral would be thought of as 2 times the integral of 1 over u du. And your second integral would be thought of as u to the negative 2 du. So the appropriate rule for the first one, your answer would be 2 times the natural log of the absolute value of u, which could be back substituted with x minus 1. And then power rule on the second one, add 1 to the exponent, divide by the result. You'll actually end up with plus u to the negative 1 over 1, or 1 over u, and u is x minus 1. There we go. All right, my friends, and hopefully that does make sense as to why we like to have constants over our linear factors. It's kind of the best setup we can give ourselves when it comes to integration. Okay, now let's take a look at part B, and then you could also look at the challenge here. So go ahead and see what you can do with part B and the challenge problem, and then check in with me in the next video. Good luck.